Okay, and the small topic talks about if you have a, I'm going to exaggerate this a little bit. If you have a very small angle for your sector, I'm going to exaggerate very small, but I think you'll get the idea. So imagine that being super close together, really tiny. Would you agree that the linear distance between those two endpoints is very close to the curved distance? Like the curved distance would be a good approximation for that linear distance. If it was really small, there'd be minimal difference between those. Okay. So the arc for a very small theta value, the arc length is a good approximation of the linear distance. So if I call the linear distance x and the arc length s, s is about equal to that linear distance. Small difference. Where did that go? Right here. So you're going to see the phrase subtends an angle. We're going to go right into an example. The Empire State Building I don't know why I capitalized all that. Subtends an angle, I'll tell you what that means in a minute, of 1.3 degrees when I am 2.3 miles away. So if this is our Empire State Building with its tower on top, you're 2.3 miles away. That subtends an angle kind of means you're standing at the center of a circle. So you're back up here. And you got your little angle measuring tool that lets you measure from the top of the building to the bottom of the building. Now realize my picture's not even close to scale because this is only supposed to be 1.3 degrees from the top to the bottom. Subtends an angle means it creates that angle when you are at the center of a circle measurement. So technically this is 1.3 degrees. Oh, I forgot to write the question down. Your goal is to approximate the height of the Empire State Building. Approximate height of building. And how we're going to do this is pretend that this is the center of a circle. We are going to find the arc length, which is going to be a good approximate value for the linear distance, the vertical distance of the Empire State Building. So we will find S, and our S will be the approximation for the vertical distance. And I know that my distance away is 2.3 miles. So now it's just a very easy arc length problem. Once you figure out what subtends an angle means, it's pretty easy. So our arc length formula, we need the fraction of the full circle, which is 1.3 degrees out of 360 on a full circle. And then we need the circumference, because that's the distance around, the fraction of the full distance around, that's 2 pi r. Realize what units you're going to be finding here. What are we going to be finding the height of the building in? Miles. We're going to say how tall it is in miles. Not a good unit, but we're going to go with it. How tall is it in miles? And we're looking at 2 sig figs. Should be pretty small. 0.052. How many feet are in a mile? If you multiply that by 5,280, you could convert this to a 2 sig fig answer in feet if you wanted. It all depends on what the question would ask. I didn't ask, but so that would be fine in miles. Okay, let's try one more of those subtends and angles, see if you can draw the picture. It's drawing the picture. Get to it. There it is. Okay, number 2. An oil tanker. Oil tanker. That is 3.1 kilometers out to sea. Subtends an angle. .5 degrees. Approximate the length of the ship. So you've got your oil tanker way out, standing on the beach, you're looking at it go by, okay? Or the shoreline. Got your little angle measuring tool out there because you're good. You're a little geek. You can measure that angle from the front to the back. So here's our oil tanker. I don't even know what it's supposed to look like. Put a couple stacks on it, I don't know. Okay, beautiful. Here you are, way back on the shoreline. So you can measure from the front of the ship to the back of the ship. Your measurement for that angle is 1.5 degrees, very, very small. We are 3.1 kilometers away. I'm out of ink. Need another pen. .1 kilometers away. And instead of doing this with a triangle, we're going to do it with our arc length. We're going to assume that the arc length is going to give us a good approximation. Because we don't have any ways to solve the triangle business yet. Oh, we probably could with the right triangle if we wanted to, but it's just another way to get there. So, arc length formula. 1.5 degrees out of 360. And then we want circumference, because we're doing length. 2 pi r. kilometers. So 81 meters if we wanted to go back to what a ship probably is measured in as meters. Okay, so that ends that section. There was the one set of story problems. I felt like I was going long on Friday, so I want to hit that. Okay, this next section, section 3.3, which we'll start a new section for, give you a whole new point for it. Oh, by the way, notebooks are going to have to grade next week sometime. So make sure you have all your notes handy and ready for next week. Probably do it Tuesday-ish. All right, calculator day and circle sheet day. 3.3. Your learning target today is going to be to determine what mode the calculator should be in degree or radian. To solve problems. Okay. Well, first off, you only need to care about your mode when you press sine, cosine, and tangent. If you're not using those buttons, chemistry class, you're not using those buttons, you don't care what mode you're in. But if you're going to touch sine, cosine, or tangent, or the inverses, you need to know what mode you're in. So that's the first thing. I only care when I use sine or its inverse, cosine or its inverse, and tangent or its inverse. Other than that, it doesn't matter. It can be in either mode, you're going to be fine. Take your physics test, take your chemistry test in any mode you want. Although physics sometimes uses some tricks, once in a while. So if you're going to touch those three buttons, you better be aware of your mode or you're going to get stuff wrong. Especially when the final exam comes in January and it's all mixed together. And we're doing these. Because I can guarantee you on the multiple choice, both answers will be there. One right, one wrong. So here we go. Example 1. Find each ratio and tell what mode. Okay, we first want to find the cosine ratio for a 25-degree angle. So we're obviously going to be touching the cosine button. What mode do you think you got to be in?
Degree.
Why degree? Because it's in degrees. Kind of tough, right? Okay, so your calculator better be in degree mode. It probably still is because we don't think we switched to radian yet. So if you're in degree mode, do you need to push the degree button when you type this in? Or just need cosine 25? Just cosine 25. We should check. Put it in radian mode once and type in cosine of 25 with the degree. And then go back and do it in degree mode. See if we get this thing. Can you override the radian? I don't even know. Just thought about it. In which mode? With the degree mark in it. What is it in degree mode? Let me check.
Same thing.
Same, so you can override it. Oh, that's nice to know. How do we do this? Know that? So you could be in radian mode if you put the degree in. Oh, you gotta remember that. Or just keep it in degree mode. So did you get 0.90?
906.
We go 4 places usually. 3?
Yep.
Okay. All right. but I don't know about this one. How about the tangent of 0.35? What mode are you going to be in here? What form is this angle in? If it was a degree, I'd put the degree mark there. So it's a radian. Because there's no degree mark here, this is automatically a radian angle measure. It's just over 1/3 of a radian. 1 radian's all the way 1/3. It's in the first quadrant there somewhere. But this is radian. So you want to be in radian mode. Can we override it if it's in degree mode? I don't know if they've got a symbol for the radian. Oh, things to think about. But go ahead, put it in radian mode. Type tangent of 0.35.
0.3650.
If you were in degree mode and typed in the tangent of 0.35, 0.35 would represent a super tiny angle. Or 0.35 radians is way big. Okay. So, the easy ones are when I'm giving you sine and cosine, and knowing what mode to be in is pretty obvious. It all depends on what your angle is. Okay? What about those goofy ones like secant, cosecant, and cotangent? Some of you got it down pat how to type that in, some of you do not yet. So let's continue on there. What if I asked for the cosecant of a 1.68 angle? Well, right away when you don't see the degree mark, you automatically know it's a radian, so you got to be in radian mode. But we don't have a cosecant button. Do you remember the 2-step process, or 1 step if you... Adam? 1 over? No. What button are you using?
Well, 1 over the sine.
Oh, 1 over the sine of 1.68.
That's what
Yeah, that's better. You missed a crucial word there for me. So realize what this is doing. It'll do the sine of 1.68 first, give you the sine ratio, and then that 1 over is going to flip it over. So it's doing 2 things in 1 step. And what is this ratio going to be? I do not, oh yeah, I do have it. Did you get 1.006?
Yep.
What about the cotangent of 3 pi over 7? What kind of angle is 3 pi over 7? That's a radian also. Remember, we can give radians in exact pi form, or we can give them in decimal approximations. It doesn't matter. It can come either way. As long as there's no degree mark, it's automatically a radian. So you're still in radian mode. And how are you going to get the calculator to give you this cotangent ratio? Yep, very just like part C, 1 over partner function is tangent. So be looking back at these tomorrow when I'm gone. Everything's in your notes when tomorrow's homework comes along. So, and what'd you come up with here?
2282.
2282? In agreement? Okay, number 2. So you just found ratios. What about finding angle measures if you know ratios? The sine of some angle has a ratio of 0.9641. Adam.
Usually -1.
do the inverse sine of 0.9641. Do you know what kind of angle I want? Do I want a degree or a radian? Can you tell? Doesn't matter because I haven't asked for either one yet. Right now, you have no indication whether, boy, does that person want the angle in degrees or radians, because there's an equivalent for both of them. So usually now, at this point, you're going to be given a second piece of information. Theta has to be between 0 and pi over 2. So it's giving you a range of values for the angle. So now, what kind of angle am I looking for? Because of this interval, radian. So you want to be in radian mode when you do your inverse. Because if you do inverse sine and you're in radian mode, it's going to give you a radian answer. If you're in degree mode and you do inverse sine, it's going to give you a degree answer. So if you're in radian mode and you do inverse sine of 0.9641, what is your radian answer? 1.302. Good. What if I want the secant of an angle whose ratio is 2.6315, but this time I want that angle to be between 0 degrees and 90 degrees. Adam?
For this one, you do cosine negative 1 over 2.631.
Very good.
But in degree.
In degree mode. So this interval, this part here, I don't know. Could be either one. But this is telling you what mode to put your calculator in. Because I want a degree answer. So if you switch yourself to degree mode, and then do inverse cosine, and Adam had it all set right off the bat. But remember, we don't have an inverse secant, but I can switch this to the cosine ratio. It's 1 over 2.6315. Now I can see very easily that to get theta, inverse cosine of the fraction. So notice the difference between finding an angle where the fraction's at and then the one from example 1, finding the ratio when they do fit. Okay. So here we do 1 divided by then the function. With the angle, we start with the inverse function first and then do 1 divided by. People get those two things confused and give me all the wrong answers. Try one more on your own. Let's go. The cosecant of some angle is, let's go 1.4421, and the angle has to be between 0 and pi over 2. So that doesn't mean you're going to have pi's in your answer, it just means you're going to be in a certain mode. Go ahead and try that one. All on your own. Let your fingers do the walking. What'd you come up with? Okay. I'm going to go 0.77 radians. Any problems with that? All right. You will need your circle sheet for the last chunk of examples. Okay, anytime we're finding exact values, that's going to tell us that our answers are on the circle sheet. We don't want decimals rounded off. So when you see this, that means use your circle sheet. Otherwise, if it doesn't say that, then you're doing the approximates and you're typing the stuff in your calculator. So and you've done enough of this stuff already. Cosine of 2 pi over 3. So it's looking for the cosine ratio at that angle. If it was an approximate, you just type it in your calculator. Cosine 2 pi divided by 3 and give me a decimal. But because it says exact, go to your circle sheet, tell me what it is. Adam?
Negative.
He sees negative 1/2. Everybody take a chance to look it up. Negative 1/2. And because we're finding ratios, mode doesn't matter. You're looking up the mode when you look up the right angle. How about the cosecant of 10 pi over 3? So if you're searching your circle sheet for 10 pi over 3, you're not having much luck, are you? No, it's not there. Why isn't it there? I don't know. I have no idea what 10 pi over 3 even equals. But if we turn that into degrees, my brain's going to know why it's not there. So anytime you can't find your radian, tick it into degrees and you'll know why. How do we convert from radians to degrees again? What's that little T-box little thing that I made you do 40 of?
180.
The 180 in the pi. So we're going to take 10 pi over 3, do our little conversion, divide by pi, times by 180. Pi's are gone. So what's 10 divided by 3 times 180? Oh, well, now we know why it's not on our circle sheet. Pretty obvious. What are you going to do with that? Subtract 360 to get it down to something that will be there. Where are we at now? So we're really just looking for the cosecant of 240. So go to 240. Cosecant is sine's reciprocal, so take the sine and flip it over. What are you going to have?
2 over square root of 3.
Negative 2 over square root of 3. Hit it. Negative 2 square root of 3 over 3. So whenever your radian's not there, kick it to degrees and you'll know exactly why it's not there. Are we good on those? Okay, then the last thing we have is still using the circle sheet, but it's finding the angle. Find angle. Okay. The cosine of some angle equals square root of 3 over 2. So again, anytime you're giving an angle answer, you should be asking, boy, am I giving it back in degrees or radians? You always have to be given a second piece of information to know. Because if you look, you really have 4 options for answers. Where does cosine equal square root of 3 over 2 on your circle sheet? Ben?
30 and
at 30 and 330, you also have the radians for those. So there's 4 answers there. Well, which answers do I want? Or which answer or answers? Well, I want the theta that is between 3 pi over 2 and 2 pi. Where's 3 pi over 2 at in terms of degrees? What is 3 pi over 2? 270, and 2 pi is 360. So I want the angle in the 4th quadrant that is a radian and has this ratio. So out of those 4 answers Ben said, I want one of them. Which one am I looking for? 11 pi over 6. 330 will get you a -1. Because I want the radian, because this interval is telling you to give a radian. So theta equals 11 pi over 6.
So does it have to say find exact theta?
No, but because you see this, that means be exact. Okay. All right. Let's try another one of these. I got a couple of these to try, and then we're going to be done. How about the cotangent of some angle equals square root of 3 over 3. Okay, we don't have cotangent on our sheet. So if the cotangent is square root of 3 over 3, what are we actually going to be looking for on our sheet? Which function can we look up? Tangent, but what do we want tangent to be? Just square root of 3. So this is what you're going to be looking up. You need a second piece of information. I want the angle that is between 180 degrees and 270 degrees. What are you coming up with here? Number 240? Okay, one more. I want the secant of some angle to equal square root of 2. So what function are we going to look up if it's secant? Cosine. What is the cosine ratio going to have to be? Not square root of 2, but square root of 2 over 2. You're getting used to flipping that over in your head and seeing it. And this time I want the theta to be between 0 and 2 pi. Adam.
So it would be pi over 4 and 7 over 4?
Mm-hmm. Because this interval says look around the entire circle, 0 to 2 pi, all the way around, and give me the angle where cosine is square root of 2 over, there's 2 spots, so you got to give me both of them. So this little second piece of information tells you a lot. Tells you what mode the angle has to be in, and where. So when it gives this, you know there's going to be 2 answers. Okay, so tomorrow I will have an assignment for you. One's going to be a worksheet packet on this stuff, and then there'll be some of those sum 10 story problems from the book. So it'll be kind of a double whammy, but you have the whole hour. I do want to pass back your test and your circle quiz. Oh, Kylie, you're going to take that circle quiz yet at some point? Yeah. Yep. Let's see, Pat. Yeah, it will be. I don't have it figured out yet. Oh, the worksheet though. I need to work it out. Don't have that copy yet. Come back. I'll copy it 4th hour on my prep. Are you going to be here all day? Yeah, come back. Yep. Come back.
I knew this morning, but I wanted to make it.
Yeah.
Well, no, it looks better. The illustration. And then
Yeah.
And plus use the entire drawing.
Why was your first hour?
That's why I'm saying.
Oh, really? This is not how we work, yeah. Hard enough to know.
That's not terrible.
Erica, Alex.
All right. Sure, my daughter was having, oh my goodness,
There you go.
scrapped it.
Oh, I did it, but I didn't know.
Too far away. How can you not like
Okay, questions on that test? There were two forms, so if you have a question, you gotta tell me which form. I can show you mine. Yes,
I have
Form
Form B
B
on 15.
on 15.
So were they looking for the angle measure this time?
15, yes.
Okay.
From north clockwise. Bearings are from the north all the way around clockwise. So you can see it down there, 15. It'd be 315 degrees. Adam.
First, how do you do the extra credit on Form A? I shouldn't have time to do that.
You gotta write your two tangent problems and then set them equal.
Okay.
Like the tangent on the inside, h over x, and then tangent out there, h over x plus 25.
Okay, so.
Get them both h equals, set them equal, solve for x, plug it back in and get h.
Yeah.
It's a lot of work.
I thought so, but I
Yep.
didn't have time to start.
Anything else that you want to see? If not, they go back in the box on top of that stuff that's in there.
What did they talk about? I mean,
We all said we changed the name and everything.
They would say that.
Oh, friggin' we just had. We had like, you didn't say anything.
Yeah, they just knew what they were.
Yeah. No. This is so, well, we only have one time because we were doing.
Like, I put it off until now. Yeah, Kaylee. I put it off until now.